Hello everyone, I'm Shahid Alanka. This is a fourth video in this tutorial. In this tutorial, I'm going to explain about encoder and decoder. First, I'll explain decoder. Decoder is a circuit that changes code into a set of singles. Then it's have variation of decoders: 1 to 2 line decoder, 2 to 4 line decoder, 3 to 8 decoder, 4 to 16 decoder. Import decoder type is 2 to 7 decoder. I'll explain one to one. And first one is 1 to 2 line decoder. This is a basic concept in decoder. It's a base for the decoder. This is the circuit and basic decoder and 1 to 2 decoder. I'll explain practical sessions and practical representation. This is a default decoder in that logism tool, and I'll implement this practical. Then this is a chart and values and diagram in this decoder. Okay, I'll default connected that 1 to 2 decoder. This is a 1 to 2 decoder. I'll that, and I'll show you how to implement that. When I input is A to 1, P is 1 and P dash is 0. Then I A is 0. You show P dash is 1, P equal to 0. Therefore, I remove this to decoder and I get default decoder. This is the default decoder in the resolution tool, and I connected this decoder has. We can, if you want to change how many bits do we need, we can choose this area 1, 2 and 3, and if you want 4 bits counter decoder, you can show. Okay, I got in 1 to 2 decoder. This decoder has first one is enable pin, this is the second one is input, then it has two outputs, first one and second one. I'll show you. If you no need the enable pin, we cannot use this. It's a enable, include enable, yes, we selected no, then it's 0. Okay, I'll input that. This one is 1. I'll input for that value. Then you can show green color is 1. Then I'll input 1. A for 1, you can show second input is 1. Second output is 1. Then I input 1, 0 for first input is 1. I'll before circuits also this concept in here. Then if you want to enable pin, we can enable that pin, enable or disable. I'll show that, and yes, means I connected the constant for that. That constant, this is the constant. Then I input one value for the constant. You can show this one is normally executing normally, but this is a I remove this one and input 0. Then I input 0. You can show anyone because of it's 0, not represent anything. Simulate. Show. Now you show it. Show exactly. It's not. Then I input 1 and then 2 inputs also. This is the enabling 1 to 2 decoder. I'll show that and hiding it in the diagram. Enable pins also not in here. Enable, I disable that pin. First one is P. I Lego. Second one is Q. Then I show the chart project turn and you can show this thing. A is 1, P is 1, Q is 0. A is 1, P also 0 and Q also 1. You sure? This is the table of this diagram. Okay. Second one is 2 to 4 decoder. 2 to 4 decoders we can represent only gates, and if not we can use 2 to 1 to 2 decoders and 4 1 2 3 4 and gates, and it's represented when we using this type of default decoder we use to 2 bits input, therefore we can get 4 output in that decoder. 0 0 0 1 you show 0 0. When we input 0 0 you can show first one, second one is 0 1, third one is 1 0, fourth one is 1 1. Let's move to that and I'll show that. And I also again created that decoder. This is decoder. I'll explain before I explore. This decoder is I have been created in this area, and I implement this 1 0 1 0, then 1 1. Okay. Because of not any output, not represented any output. When I input 1 and 0, 0 and 1. Why? What's the problem? Problem is enable pin. I enable pin is disabled. We have enabled that panel. You can show in the output 1. When I input 1, you can show second one is 1 1 is a fourth output. This is the 2 to 4 decoder. I show 2 to 4 decoder another type, and it's a default value decoder, and input enable pin also on. I remove that enable pin. I don't need that. It's not compulsory now. And decoder input. I get 2 to 4 decoder. Therefore, select bits are 2. Then we have 4 outputs. So this 1, 2, 3, 4 outputs in here. Then I input in the 1 outputs for the LEDs. I use for LEDs for that. Then for LEDs in here output. Why it's in orange color? Therefore this is 2-bit decoder, but I input only 1 bit. Therefore I change that data bits also 2. Then you can show first bulb is blink. Then I input first one, second bulb is on. Then 1 0, third bulb is on. 1 1 is fourth bulb is enable. This is the 2 to 4 decoder. Then 3 to 8 line decoder. 3 to 8 line decoder is a complex one. Therefore, I'll explain this is a normal and it's a whole circuit. Complex circuit is normal circuit. This is it's a complex one. You sure? This is a complex one. Therefore, we created 2 to 4 decoders and it connected in the normal service. Then 3 to 8 decoder. This is a 3 to 8 decoder using 2 to 4 decoders. I'll explain that. This is a normally represented symbolic representation is this is, and I'll show you. Therefore, I have already created 3 to 8 decoder. I'll show that 3 to 8 decoder normal representation in this. This is a normal implement in the 3 to 8 decoder. It's very complex and we have to connect it this type of in this connector, and if not we can use 3 to 8 normal decoders for 2 to 4. This is the 2 to 4 decoder I have already created. This one is created and we can use this area I have created 2 to 4, and second one we can use that. So this is the decoder type. Then I already used this circuit for that 2 to 4 decoder, and you can show enable pin and everything in here. 1 and 0, 1, show this one. Then I input it. If I using 1, you can implement second one, and 1 and 0, you show this type of things in here circuit 3 to 8 bit decoder. And let's move to the 4 to 16 decoder. 4 to 16 decoder is most important one, and it's very complex. Its decoder has 16 type of variation inputs. We have inputs only 4 inputs, and outputs are 16 type of, it has 16 type of variations. Then I'll show that it's a complex because of I already created 4 to 16 decoder. This is the 4 to 16 decoder. Then I implement into C is 1, not in any other, and D is 1, oh, and I put E is 1, C is 1, because of this is the enable pin. When we implement these decoders, if we want to execute that, before that we have enabled that enable pin. If not, we have and we must remove that enable pin. If not, we cannot execute that circuit. Therefore, now you can show what are the outputs in this circuit. So output 1 is a different type of variations and different type of outputs in 4 to 16 decoder. This is I already created because of this is very complex, and this is first 2 to 4 decoder, this is second 2 to 4 decoder, this is the 2 to 4 decoder. I change that location 2 to 4 decoder. 16, this is a 2 to 4 decoder also, this is also 2 to 4. Those every 16 outputs in here. Then 2 to 7 segment and 2 to 7 segment decoder. Then 2 to 7 segments very important to human. Therefore, we using 4 digits represented digits binary codes and 1 to 9 all number representing this using for this decoder. And this is the concept, and this is the 1 2 3 4 5 usual is 2. This type of things output display panel. Then 20 segments as connected display board. Then when we connected the display board, we can show that numbers. If you want to represent number, we have to input binary code in here 1 and 0, only 2-bit code. You can show that this is the 2 to 7 segment decoders complex, the original circuit, and this is the simplified circuit, and this is the original circuit. Then when we input the display board for the decoder, we have rules. This is the rule of connected display board. First one is G value, F value, third one is A, fourth one is B, is E, D and C. This is the dot value in here. This is the dot value. If we put into 1, we can show the dot in display board. Those are the representative table, and The most used applications combination encode designing the binary to 7 segment. There are 7 segment given according. I'll show that this is the I already created those all tables because of if I created this in this lecture series, it's going to many more times. Therefore, I already created that 2 to 7 segment normal decoder. This is a normal decoder, and it's very hard to design. And I simplify that under another table, another file. This is a 2 to 7 display. This you can show this is the 2 to 7 normal one. Yeah, sure. Okay. And this is the display board. 4 inputs. It's a binary code. Those are the binary codes. And this is the display board. When I input, this is the 1. If I want to represent 1, I have to input this input for 1. Sure, this is a 1. Then if I want to 2, show the 2. This input 1 and 0. Now show binary representing 1 and 0. Decimal place is 2. Then I need to 3. This 1 is binary representing and a decimal place. 4 is 1 0 0 0 1 0 0. So this is a 4, and then 5 and 6 is 1 1 1. 6 7 6 is 1 1 0, and 7 also in here. 8, how I represent 8? 8 is 1 0 0 0. It's a 9. Those are the values in this decoder. We can use decoders for the displaying binary values to decimal values. Then encoder is reverse of the decoder. Encoder says sensor translate physical motion into electric data. That data can be used by control device. Then determine speed, actual positions, encode reverse type of decoder. I also mentioned that 2 to 1 encode implemented by reversing the 1 to 2 decoder. This is the encoder and input 4 values, and you get only 2 values. It's simplify. This is the representation of the encoder and encode. I already created encode. This is encode. And I input 1, you can show out 1, then 2, 1 more. Output is 1, 3, 1. You can show again. You can get same output. D2 is 1 and D3 is 1. Other one is D1 is 1. So those are the encoder, and it's a normally basically 1. You can show this type of things. Also 0, 1 and 0 as you wish. You can get valuable, and if you want get to your value, you can change those inputs and you can create your output. Then those are the encoders and decoders in this tutorial. I think you can understand about it very well. Thank you.